the Clean Call. I am Kristen Poppleton, your facilitator for this 60-minute experience. And I'm really excited to hear from our speaker today. But before we get started, it's always nice to just kind of go around and do a little intro to see who's on the call, and maybe save any big announcements for the end so we can respect our speaker's time. I was thinking, so here I live in Minnesota, and I'm jonesing for some spring, even though I love winter. And so I was thinking everyone could share their, introduce themselves and say what's their favorite sign of spring. And I will start. Mine is that it's warm enough. The sun is now blinding me a little bit more, although it's because it's reflecting off the like 8 feet of snow we still have, but like there is a slant to the light that is indicating there will be spring someday here for us. So, and I work at Climate Generation, and I will pass it to Frank Granshaw.
Hey, hello. Well, Frank Granshaw, Portland, Oregon. And I'm adjunct faculty with Portland State, and also work with Creation Justice program at Ecumenical Ministries of Oregon. And I guess the exciting thing for me is the fact that we don't have eight feet of snow, Kristen, but we had 8 inches of snow, which was a big deal for us in one day. And all of that's gone now. So I think with that one, I'll pass it over to Carrie, who's next to me.
Thanks, Frank. My name is Carrie Herndon. I'm the curriculum specialist for the National Center for Science Education. When I lived in DC, my favorite sign of spring was the cherry blossoms, very iconic to that area. I'm no longer in DC, but it's still something that I think of whenever I think of spring being around the corner. And I'm going to pass it to Anne.
Thank you, Carrie. I'm Anna Gold. I'm with a series here in Boulder. We actually had, I moved to Boulder in 2009, and it's the 3rd coldest winter we've had in since then. We've had a lot of snow. We had freezing rain this morning, and but I love skiing and I love the mountains in the winter. But I have planted some tulips, and I'm always looking. I've been checking on my tulips if they come out, and they haven't yet. I'll pass it on to Alyssa.
Hello, my name is Alyssa Dahlman. I'm currently a graduate student at UT Austin, and I live in Austin, Texas. So actually spring has already begun, and it's going to be in the 80s this week. But I'm just on the call because I'm currently looking into engaging in a career in science communication and outreach. And so I thought I'd see what the talk was about today and just kind of see what it's all about. Thank you for having me. I will call on Emily.
Hi, everyone. I'm Emily Snowd Brenneman. I'm with UCAR is University Corporation for Atmospheric Research, and I'm with the UCAR Center for Science Education. I'm a program specialist, and thinking about spring, I always think about the crocus starting to pop up through the snow, and also the meadowlarks when they start singing their hearts out. That's just spring to me. And I will pass it to Eric.
Thanks so much, Emily. Eric Havel with the Community Resources for Science nonprofit, do a lot of environmental, climate science, literacy education for teachers and for students here in Oakland, California. So, you know, the classic golden poppies are sort of emerging all over the median strips and the wild spaces in Oakland right now. So that's awesome. And just we're happily, I mean, it's been crazy, the atmospheric rivers that have been pouring through California, but they really have helped the reservoir situation. The snowpack is way improved from this sort of, you know, huge drought that we've sort of been going through. So it's exciting. And even though it's been almost like too much of a good thing, and we're expecting another like week and a half of it. It's been good for things overall. And I will pass it to, am I saying it right, Aditya?
That's perfect. Hi, everyone. My name is Aditya. I am the speaker for today, and I'm excited to share some of my research and some of my work with all of you. I wear two hats. I am both the co-founder and CEO of a virtual reality education company that works in the space of science and STEM education called Inspirit. And I also am a researcher and will be finishing my PhD at the Stanford Graduate School of Education in 1 month, where I've been studying all things around VR and STEM education, and more specifically, VR and environmental education in the context of science and STEM. And I'm excited to share some of that work with all of you today. I live in Palo Alto in the Bay Area, and so similar to Eric, we've been getting very weird weather over the last few weeks, but very necessary rain. And I've been seeing a lot of rainbows because of the combination of rain and sunshine around me, which has been very nice. I will popcorn it to, let's see who's left. Maybe Frank.
Sorry about that. Lots of problems on my computer. Nice to be with you all. Sorry for being late. Frank Niepold, NOAA Climate Program Office, Climate Education Lead. Is that the popcorn you need?
Your favorite sign of spring?
Favorite sign of spring? I mean, the wildflowers are always my favorite. The mayapple. When the mayapple is blooming, that's a good sign for me. That means I'm in the forest a lot. Is there somebody who should be popcorning too, since I was late?
Karen hasn't gone, or
Carolyn.
or Carolyn.
Carolyn, why don't you go?
All right. So I'm in North Florida. I work with the Clio Institute. That's climate focused nonprofit throughout the state. And we did actually have a pretty cold winter this year. But for me, for the first time in several months, I noticed some of the little anoles running around on the sidewalk sunning themselves. So for me, spring means that it's warm enough that the lizards come out of hibernation. And I'm so sorry, I'm not sure who hasn't gone.
I think Karen hasn't gone yet.
All right, Karen, it's up to you.
It looks like Karen was having some audio issues earlier too. I don't know.
Should I go ahead?
Yeah, why don't you hop in, Jim, if you don't
Get
mind?
ready to come in when you can, okay?
Yeah.
So I'm Jim Callahan with Mobile Climate Science Labs, and in spring, a different type of blossom happens in the Bay Area. We start to have 10 different STEM festivals that are mass scale. It's a chance to get the clean network out to the public. We meet teachers, we meet principals, and this weekend we have 15,000 people we will be with in the wine country, northern Bay Area, and I'm going to be listening to you about VR and Stanford, because are you going to be at them? Because VR does very well at a lot of the STEM festivals, so maybe you'd want to take part in that. Stanford's at some of them too. Okay. Anyway, Karen, do you want to give a shot, or should we bring you in at some point?
Seems like Karen's audio is delayed, so we'll move ahead. And Karen, you can drop a note in the chat if you have access to that. Well, great, thanks. It's so fun to hear everyone and feel the spring that I don't have yet coming through in your parts of the world. That's the fun part of this call. I always feel like, just to be with people from all over. And I'm super excited to turn it over to our speakers and I know we've already done a little introduction, but let us know if you need anything. We're here to listen. And if folks have questions, would you rather they held them to the end or ask during, or?
Yeah, I am open either way. I only have like maybe 15 to 20 minutes of content I want to share, and then I'm happy to open this up as a full discussion. So even kind of happy to be interrupted at any point, just maybe raise your hand or something, because I wonder if I screen share. I'm not sure if I'll be able to monitor the chat as closely. So feel free to raise your hand and I'd be happy to pause to take any questions. But thank you for having me here today. This is an exciting community to connect with, and I'm glad that I have this opportunity to spend time with all of you. To give you some context about me before I jump into some of the slides that I have here, I do all things education technology. That's my research. That's my work. That's been my all the stuff I've been doing as both as an entrepreneur, as a nonprofit founder, as well as most recently running this VR education company. We think a lot about the intersection of curriculum, of classroom pedagogies, and new emerging technologies, specifically looking at how we can use them meaningfully to drive engagement, to drive learning outcomes, to drive measurable kind of growth in student classroom outcomes. I come from the background of having been a victim to, as well as been a part of systems where technology is often airdropped into schools or into learning environments, largely because it's new or because it's cool or because it's a shiny new piece of tech. And I come from that mindset of that's no longer the way we need to be doing things. We need to be thinking much more, drawing from a learning sciences perspective of the science of learning, really looking at how and why people learn and how can these technologies be leveraged to drive those sorts of outcomes. In that vein, whatever I shared with all of you today is really a group effort of a lot of people and a lot of stakeholders, and I'm just representing a very small portion of an incredible amount of work that has gone into this thinking today. Half of the resources that I will be sharing with you come from this company, Inspirit, which is a large team of engineers, designers, artists, former teachers, a quarter of a team of former K-12 educators from science classrooms across the country. And then the other half of my work, which I will be sharing, comes from more an academic perspective from a few different groups at Stanford University, from the Stanford Virtual Reality Lab, led by Dr. Jeremy Bailenson, who has been running one of the oldest VR research labs in the world probably right now, the Stanford Graduate School of Education, which is where I did my PhD, as well as some links to a couple of collaborators at the new school, the Doer School of Sustainability, which was just founded at Stanford a few months ago, which looks at all issues around environment, sustainability, and climate change. I'm going to now go ahead and share my screen, and I'm really excited to introduce Inspirit to all of you. Inspirit was our endeavor. It was a research idea first, and our endeavor to really kind of take experiential learning at scale and ask this question of how can we use virtual reality to drive that sort of immersive engagement and learning in the classrooms. Teachers like to call us the magic school bus for the classroom. If you ever watched that TV show, that's exactly what this is. You put on a headset and you shrink in size and you enter the human body and you learn about the cell or about the DNA as if you were floating around a cell with the organelles, or you're on a different planet learning Newtonian physics, except now you can change gravity, or you can remove air resistance and understand what's happening, build that intuition behind the laws of motion. Or in the case of environmental education, you can actually immerse students in spaces, reducing that physical distance that might be necessary for them to experience or visualize or see what's actually happening to the environment around the world, especially if they're in a bubble of their own and are not able to see visible impacts of that in their neighborhoods or in their surroundings. We work with hundreds and dozens of districts and schools across the country and also now around the world. And I would love to chat with you if you want to find ways to collaborate with us and bring VR in any form or function to your classrooms. But my goal for today is to really answer this question of why should you, as either academics, researchers, practitioners, even care about this technology? Why is virtual reality interesting, and why is it relevant to the work that you do and that all of us do in one way or the other? And I want to start with a very simple example that we often do whenever people visit the VR lab at Stanford campus. It's this really cool experience called the Walk the Plank simulation. And humor me while I explain this to you without actually having you put on a headset and experience this. If you had a VR headset with you, and if I was able to give you this demonstration, you would do exactly what these screenshots look like. I'd put you in a headset, take you to the top of a skyscraper, and make you walk this plank. And it's really funny because you'll have other people around you that are going to be laughing at you as you stumble and you nervously walk this plank, while you consciously know that this is a completely safe and a completely harmless experience, right? I mean, even if you look at these images, you'll see that these are computer generated images. This is not even a real city. This is not even a real skyscraper. It's all animation. It's all CGI. Still, as you walk this plank, if you have even a remote fear of heights like I do, you will see my palms will start getting sweaty. My heart rate will start increasing. If I had a sensor on me, my forehead will start getting sweaty. And at the very end, we would ask people if they'd be comfortable jumping from this plank. And some people say they'll jump, and when they jump, they scream, they yell. It's really funny all around. What's happening is, while the front part of your brain, the cortex, knows consciously that this is a fake experience. I mean, it knows that this is not real. It knows that you're on a safe, stable ground in the real world, in a floor, on a floor that's stable, that's not on the top of a skyscraper. The real part of your brain, the one that's responsible for the fight or flight response in your body, has not significantly evolved to a place where it can recognize this difference. So the real part of your brain is actually generating the same physiological response in your body as if you were on an actual skyscraper. It's going to cause the same adrenaline rush, the same increase in your heart rate, the same sweaty kind of sensations everywhere. This is an effect in social psychology that we can measure. It's called presence, and it's a measurable construct. It is this ability to subconsciously fool your body, not your brain, just your body, into believing that it is somewhere else. This is what makes virtual reality very, very unique, is this ability to fool your body into believing it is somewhere else subconsciously, while you consciously know, of course, that you're wearing a headset and that you're not in any form or function of any danger. So my research and the questions that we asked were, well, what happens if you apply this to learning? What happens if you apply this to a science or a STEM classroom, and give students this sense of presence, take them somewhere else subconsciously? Could that have any significant impact on learning? And the lab at large ran a series of experiments around this. And I looked at stuff in K-12. They ran a series of experiments, and I'm going to share a couple of additional examples with you. The first question they asked, one of the early questions they asked were, well, we have evidence that shows that children that play violent video games tend to show violent tendencies in the real world. So what happens if kids play altruistic video games? Will they show altruistic tendencies in the real world? And so in the same VR example, this was a superhero VR experience. You put the kids in a headset, they're flying around like this person is in this image. They're flying around as a superhero through a city, and they're given a task where the city is on fire and they have to find a baby that they have to save from a building. Again, all animated, all hypothetical, but they're playing this real-time video game. They're embodying this superhero flying through this simulation to save a child. In a control group for the same experiment, they had participants just wear a headset and watch a city passively through a helicopter that was giving a tour of a city that was burning of some kind. And so in one case, you're playing the active role of a character in an altruistic context in the headset, and the other is a passive role. And then we ran experiments where when you take off the headset, we had someone in the lab, usually me or someone else, fake an accident where they drop their pens or pencils on the floor, or they drop a bag on the floor, and we measure the reaction time that it takes for the participant to react to help. And we noticed that those that played the role of the superhero in the active condition had a shorter reaction time. They tended to react faster, or potentially exhibited help-giving behaviors with a significantly shorter reaction time than those that were in the passive context. This was just the beginning of a series of experiments around learning transfer. If you were learning a certain attitude or behavior in VR, could that transfer to the real world? We said, well, let's take this forward. And if you Google this experiment today, this was a very popular experiment on the context of climate change that they ran, where they said, okay, what happens if we take kids underwater and have them experience coral reefs and look at what happens to coral reefs over a period of time? So over a time lapse, have them engage with the marine wildlife, and then describe to them visually around them by making them feel present underwater what's happening to the marine wildlife due to an increase in ocean acidification, for instance. If you Google the Stanford ocean acidification experience, this is available for free online. You can check it out. You can play with it. There's a bunch of peer-reviewed papers around this work as well. Essentially, what they were able to demonstrate was that just through this 25-minute odd simulation, these kids displayed a large shift in attitudes towards the environment, a large shift in their understanding and retention and recall of information that was presented in this when compared against various control conditions. The same thing delivered on a two-dimensional screen, the same thing delivered via a live interactive conversation. In every single case, VR tended to outperform in terms of results. And really in many other cases, students also started exhibiting pro kind of climate conservation behaviors, where they were now more likely to start turning off the lights and fans, more likely to start recycling as a consequence of watching this experience. So this was really the aha moment where we noticed that VR could potentially be a tool for positive behavior change and positive changes in attitudes and even understanding of information, which was unprecedented for any digital technology till today. Now, the lab, of course, did a series of other experiments around this idea of body transfer. I was not a part of this work, but I thought I would mention it in case it was interesting to some of you, where they would put you in the avatar of somebody of a different gender, a different sex, a different race, and they would have you experience first-person perspectives in short spans of time. And the idea was to kind of understand whether there were changes in one's attitudes, unconscious biases, empathy, lots of other experiments that demonstrated very, very compelling use cases for virtual reality around this idea of embodiment in an avatar of something that is not you or somebody else of a different group or a different background or a different community as you. If you Google them, some of these were also presented as films in Tribeca a few years ago. The 1,000 Cut Journey was a collaboration between the Columbia School of Journalism and the Stanford, where they published a movie that was made on racism in America by putting you momentarily in the shoes of a Black man and seeing a day in his life through this VR experience. So some really fascinating use cases of this technology. What I did for my research with this group was to really kind of ask this fundamental question of, well, virtual reality is really a buzzword in many ways for most people, and it spans a whole range of technologies over the last 25 years. VR is not just about a box on your head. We look at virtual reality as a medium of expression, as a medium of learning, a whole new medium of communication, just as video, just as audio, just as text VR is just another medium of communication, but it can be looked at in different ways depending on the hardware that you use to access it or use it. And so we developed a very simple matrix that looked at classifying the different types of VR. Some of you might have seen 360 videos on YouTube. Some of you might have watched mobile VR, where you take your smartphone, put it in a Google Cardboard-like device, and put it on your head. That tends to have very high immersion, but very low interactivity, where you're not actually interacting with the scene. It's typically like a passive video that you watch. And sure, it's 360, it's all around you, like a field trip to the Great Wall of China or the South Pole, but you're not actively interacting with the scene. At the other end of the space spectrum, you have a lot of these desktop VR platforms. I mean, think games like Roblox and Minecraft, complete what they call metaverses today, complete avatar-based worlds and environments, but it's played on a 2D screen. It's not a headset, so it's not very immersive, low on the immersion, but very high on the interactivity. You're creating stuff, you're constructing stuff, you're building stuff, very, very high. And then, of course, the high interactivity, high immersion on both ends is the Oculus VR headsets, which you may or may not have heard of. These are what we call the 6 degrees of freedom head-mounted displays, which you put on your head, and then you can kind of access, and you get 2 hand controllers. So it's very interactive. You can do a lot of things. And then it's also very immersive because you're putting on this headset and blocking all external light. When we looked at the research, while there was a lot of hype, and this is from 3 years ago, around how powerful VR could be for learning in the classroom, we said, let's segment the research into these 3 buckets, and let's look at what we know about VR for learning in each of these 3 categories. And you'd be surprised to actually learn when we looked at some of the key high-level findings, and there's a whole series of systematic reviews that we did here. First thing we learned was that findings on immersive VR were conflicting. while there was a lot of kind of positive indications that it could offer something for learning, there was actually no general consensus that VR was improving learning outcomes or retention back like three or 3.5 years ago now. And we noticed a huge reason for this in K-12 was because all of this was happening in the lab as experimental studies and not really happening in a real classroom with actual teachers and actual students. And there was an actual kind of design-based work happening in the context of classrooms to measure and evaluate what this could look like. Prior work also did not look at different types of learning. So like procedural learning of tasks. So think of a process, something like DNA replication or protein synthesis that you might want somebody to learn by doing a series of experiments versus just definitions and words. Like what is a mitochondria? Like, is that the right use case for VR, or is VR more suited for procedural tasks? And of course, individual differences, some different types of learning styles, different types of any sort of individual difference among students was not considered in prior work. We didn't know if VR worked especially well for certain subgroups of students, maybe students who have certain learning disabilities or learning differences. Like, could they find VR to be even more compelling? We had no idea back then. Like, there was no research that was done, or there was no consensus developed around this stuff. At the same time, what we had learned was that desktop virtual learning environments, so the stuff like Minecraft and Roblox, there have been a bunch of platforms like that have existed for almost 2 decades. And we said we could take a lot of learnings from those and bring them to this world. We learned from that world, if you've played games like Second Life, which has been around for 20 years, or if you have anyone in your family or friend group that plays on Minecraft or Fortnite or Roblox, we learned that for all of these programs, what made these things work, what made these sorts of desktop-based virtual experiences work was curriculum design and lesson plan development. If you're a teacher, you're probably rolling your eyes reading this, like this is a no-brainer to you. But sadly, there was actually very little academic work that brought or married this understanding with the cutting edge nature of the technology. There wasn't any work that had shown that the pedagogy and learning science theory integration is what pushes the technology beyond its novelty effect. Very often, the first time you do VR, you're blown away because it's cool, it's new. But when novelty wears out, how do you sustain those outcomes? That's only possible when you really think about the pedagogy of how this is integrated into classrooms. And then there are methodologies like design-based research. I have a researcher named Chris Dede, who works at the School of Ed in Harvard, that does a bunch of work around multi-user virtual environments, what he calls MOVEs, and has demonstrated how these can be used to positively change one's attitudes, retention of information, behavior, above and beyond anything that we have seen today. Like VR, when done well, outperforms the best of the best tools and resources we have that we present our kids with in the classroom today. And so it's really been blowing us away in terms of looking at what this technology can unlock for experiential learning. Mobile VR, if you've ever used Google Cardboard before, it was one of the most popular things in K-12. A trade-off is 3 degrees of freedom. That's what those devices used to do. It still is the most affordable form of VR because it costs $2 to buy a cardboard headset and then slide your phone into it, and then you can access very rudimentary, very basic VR. However, the challenges are it causes motion sickness because it's gimmicky. It's not calibrated the right way. It's very hard to calibrate it correctly, and it can be challenging to use for long periods. However, there is evidence that it can drive learning and retention. And Google Expeditions is a very popular science VR learning app, which you all should definitely check out. It's a free application where you can take field trips to anywhere in the world. You can take a field trip to a rainforest, a field trip to a desert, and actually spend some time exploring that space. It's not interactive, but it's like a 360 image. It's Google Street View map data that they pull, and then they generate these visualizations of different parts of the world. So we've been doing a lot of work around the design behind how one builds these experiences, a lot of different things in context of all of this. My work was taking VR outside the lab. We said, let's do 2 things. Let's first embed these in classrooms, and B, let's actually give agency to teachers and students to create these experiences and actually edit and build their own VR experiences. So over the last 3 or 4 years, we have run a series of experiments in Atlanta, Georgia, working with multiple school districts in the region, having students not just watch and use VR in the context of a science classroom, middle and high school, but also create their own. We gave them storyboards where we said, look, here are complete storyboards, but you can design your own templates. If you've ever done storyboarding for a play or a documentary or a movie before, this is a 360 storyboarding template, where in the middle, what you see here is the person in the headset, and then these are just color-coded gradations that show you what objects should be in your scene. And your scene is no longer just in front of you, your scene is all around you. So it's a fascinating learning experience to give students agency to create and tell stories. And what happened in Atlanta was these kids started making stories on hunger and homelessness, on pollution, on waste management, on climate change, on a series of real challenges that they were experiencing and they believed could create empathy if they were able to give a first-person perspective. Let me show you what it's like to be working in a food bank in my city. And let me put you in the shoes of that food bank volunteer, and maybe you will be inspired to join the food bank tomorrow. And we ran a bunch of studies around this to show how students were developing a huge shift in their attitudes and their learning of this information by immersing themselves in these movies and these spaces. We took this to India as well. For over the last 6 years, we worked with the Google education team in a science classroom where we took students all around the world showing natural science, life sciences by embedding them in parts of the world in environments that were not local to where they were. And we measured, again, changes in the increase in likelihood of students raising their hands in the classroom, more active participation, and this persisted in the long term, even beyond the novelty period of these technologies, which made this very, very compelling for learning and for education. With Inspirit, we just completed a large control experiment in Cobb County, Georgia. This was done across multiple schools over a 3.5-month timeline of over a longer time period of time. And it was done in a biology classroom. And we showed that just 15 minutes of VR a week, that's all it was of this is immersive VR, led to a huge increase in self-efficacy and confidence among youth, specifically underrepresented youth. So students who were either in the bottom 25 percentile of a science classroom or students who were largely underrepresented in a science or a STEM context showed even higher gains than the numbers that you are seeing over here, especially for knowledge retention, spatial reasoning. It was a home run. VR outperformed any and every other control condition that we were able to develop. And it was really incredible to see these results. This is also backed by a whole decade of peer-reviewed work that we have done, which really led to our conclusion that this tool effectively outperforms every other digital tool out there today, particularly for the students who are the most underserved in the classroom. And this should not be surprising for anybody. What this is telling us is that the kids who are not doing well or who are falling behind in our STEM classrooms, our science or math classrooms, so they are not falling behind because they're not smart. They're falling behind because the way we teach them is not inclusive. The tools we use for teaching in a science or a math classroom today are largely still PowerPoint presentations and text and slides. And science, especially science, is supposed to be experiential. And that's what we're trying to shift here by building a whole curriculum for teaching these topics in a more immersive way. We think a lot about implementation as well as a company. That's why we chose to build a company and take it outside research and to scale the work we did. Implementation is very important to us because for this to work at scale in school districts, you have to be COPA, FERPA compliant. You have to have kids-safe technologies and guidances in place for how to make this the best possible safe experience. Device management, when you have 50 devices across a building or across a district, how does someone manage it and support students real time to use these things? We have a giant catalog today of biology, chemistry, physics, math, and career and technical education curriculums across the field of STEM, and actually even going into the social sciences at the end of this year. And we're really building out if you want to think of it as the Netflix for virtual reality, where we're just building new titles, new VR experiences for schools, and really taking a very bottom-up approach of working with teachers. 25% of our team today are all former teachers or administrators who are developing these simulations for the classroom. Implementation is flexible. This is important too. We work out of class, in remedial classes, and after school programs, as well as in formal classrooms. All of these. We also work on home learning, distance learning, one-to-one programs. There's all sorts of use cases here that are possible. And again, by design, this is what allows for sustained integration. This is important because for most classrooms and most teachers, VR to them was this thing that they did at an expo or at a festival that one time, and now it's something that's collecting dust on the shelf. And so it was very important to actually shift that mindset and find a more teacher-first way to integrate this. And we are now today one of the, if not the fastest growing VR program in schools in the US, even though this technology has been around for almost 6 or 7 years. Like no one's really been able to figure out how to support teachers with training and all of these other things that are necessary and critical for this to work. So I'm wrapping up with like a couple of slides on what's next. Now on the research front, what we are actively doing, and I'm happy to share some of these findings and some of these research ideas with you. If you're interested, please feel free to reach out to me. We're thinking a lot about infrastructure. We're thinking a lot about standards alignment, but we're also thinking a lot about doing even longer term studies over year timelines or like grade level kind of timelines, really look at what this technology can do when it truly is becoming a core part of curriculum, especially in a science classroom. And then my dissertation specifically looked at student authoring with VR, so actually giving learners agency in the context of climate change, where we put them in a series of virtual field trips of topics of climate change around the world. And we actually had a global community of students from representing, I think, 5 continents that participated in the study. And we were able to show that when you give them more agency, when you give them more control, and it's a less of a passive experience, they actually demonstrated a huge shift compared to the control conditions where the agency was less in retention, in recall of information, and also a change in behavior. There was a huge shift in intended behavior, attitudes, and that connectedness to nature that we used to measure kind of students' connectedness and attitude towards the environment. The gold standard really for all immersive VR is to cause behavior change. We don't want it to stay limited to belief change, but we want to motivate someone to start acting on the information that was presented to them, inspire them to act on the information that was presented to them. With Inspirit specifically, we're working with dozens of districts running at scale programs, evaluating the efficacy of these tools. And we're growing the team as well. We're looking for more partners, more content curriculum partners. We don't have a large enough environmental education curriculum, as large as it should be. And we would love to collaborate on that front, as well as on kind of just bringing our core science and STEM curriculums to your spaces. That's all I had. I am happy to pause there. I'm leaving an interesting quote that inspired a lot of this early work, and I'd love to take questions.
Thank you. This group usually has lots of questions, and I see a hand up already. Go for it, please.
Hi, thank you so much for the presentation. It was wonderful. I have 2 quick questions for you. One is if you could talk a little bit more about what the kids do in the environmental activities you talked about in your thesis.
Mm-hmm.
And the second is why VR, not AR, or how well can you integrate them?
Yeah, fantastic questions. I was hoping for someone to bring up AR, and I have an interesting take on that. But I'll start with the first one. So on the context of my thesis specifically, what we did over there was we had the students do a couple of things. So we curated a collection of virtual field trips or 360-degree VR experiences of things like melting glaciers or underwater expeditions of coral reefs and what's happening to coral reefs across multiple island nations, or talking about like stuff, basically things that were typically inaccessible or very hard to access if not for an immersive experience like this. And then in terms of giving them agency, what we did was we had students actually start authoring their own first-person narratives or perspectives using this. So think of this as if this was an actual field trip. You'd give kids cameras and say, capture moments of interest. The idea is you want to train students to know how to see and how to find things that they should be seeing that can offer them information and context about this space. We did exactly that in a virtual context. We said, let's teach you to notice in VR by putting you in VR and then having you annotate and select and identify interest points, moments that pique your curiosity, your interest, your concern. We then correlated that to their learning. We also used the artifacts that they created through the noticing, the images, the screenshots, the annotations, to structure a guided conversation where they had a multi-stage learning discourse where they either critiqued each other, asked rebuttal questions, refuted each other's claims. And there were multiple conditions where one group just watched it passively, one group watched it and talked about it, and then one group watched it, talked about it, annotated it. And in the annotation scenario, the one where they were doing noticing, of course, the outcomes outperformed all the other groups. And essentially, we were able to show an increasing level of agency when provided in a virtual context can dramatically increase connectedness to the environment and actually change one's intended behavior as well. Your second question about augmented reality is a good one. So I see augmented reality solving a different problem. And for those of you that haven't experienced AR before, augmented reality is bringing virtual objects to your physical space. Virtual reality is taking you out of your physical space to a whole new environment or a whole new space. So actually at Inspirit, we are building augmented reality content, but we're building AR content largely for math, because we've identified a lot of very specific use cases in math around visualizing a three-dimensional structure or a graph in your classroom with your peers to be very powerful or to be very useful. As a use case, we're also doing some stuff in science as well with AR, like bringing in 3D models of anatomical things, human body, organ systems, molecules, atoms into your physical space. So you can collaborate with your peers or you can visualize it on your table. Whereas with VR, it's solving this problem of kind of taking you somewhere you cannot go, like the inside of the human body, or underwater for underwater expedition, or a space station, for example. That's the way we're thinking about VR. And they solve different things. They have different use cases. Together, they can be very powerful, of course, because they can be more comprehensive as an offering.
Frank, do you have a question?
Yeah, I do. First of all, it's Aditya, is that?
Yeah, Aditya. It's fine.
Yeah. Wow. This is really exciting for a number of reasons. I did my doctoral work in the design and use of virtual field environments and teacher education in the geosciences. And I mentioned that not to show off, but rather because there was something that popped up during the teacher workshops. So I'd go in and present these virtual reality environments that were based on the field trips they did during the teacher workshops. So they had something to take back to their kids. But during one of those workshops, I had one of the teachers come up to me and say, "Hey, do you have a template for doing this? I would really love my kids to do it." And that has really set loose a whole line of thinking about actually getting students to develop virtual reality environments as a way of doing field work and as a way of really becoming familiar with it. Have you folks at the Stanford lab done anything like that?
Oh, you're so spot on. So actually, less so the VR lab, but the Graduate School of Education has recently put out a call just a year ago or so on actually designing or for research proposals around virtual field trips specifically. And a big kind of, I would say, next step for the work that we just concluded is what you just said, is actually kind of enhancing these media tools as authoring tools or as tools for data collection, and creating maybe even scaffolds or rubrics that enable a novice or a new user to be able to use this the same way they use a camera on their smartphone for data collection. Like, could you actually collect 360 VR data and then make meaning of that data by allowing people to remix it, author it, annotate it, build their first-person dives and perspectives into this. So the scholar that has been doing a lot of this work at Stanford is a professor by the name of Roy P. Roypea, like the vegetable. And he has been kind of thinking a lot and has written a lot about kind of this idea of guided noticing and using panoramic field trips for storytelling, for research, for training and teaching as well. I believe some of the early use cases for this stuff was actually teacher education and teacher PD, where they would record classrooms in 360 and then put teachers in these scenes and have teachers understand what would happen in a classroom, like help them to do better noticing and better support. It's like, well, that group in the corner, this group in the front, how do you divide your attention, your time, your focus, your space? Like, there's a lot of very interesting academic opportunities that emerge with this new media authoring tools, especially as they become more affordable and more accessible. If you asked this question 10 years ago, these devices were probably tens of thousands of dollars, and today they're like a couple $100s, right? To buy a 360 camera is relatively very affordable to what it was even 10 or 15 years ago. So the opportunities become even more relevant today.
Yeah, along those lines, are you familiar with a package that's called Hollow Builder?
Hollow Builder? No, I'm not.
It is actually a way of doing virtual reality documentation of construction job sites. Company comes out of Germany. They've got an office in San Francisco. And it is very simple to use. It's built to be able to have construction crews go through and just keep regular track of what's happening. Anyway.
That's very cool. I mean, there you go, right? I mean, no-brainer use cases, and I think that's really exciting. Thanks for sharing that. I made a note of it.
Yep.
Did anyone else have any questions or comments about this? Super fascinating. Eric.
Thanks, Christian and Aditya. I'm just kind of reflecting on like the way you know, your quote at the end from Peter Lee about sort of the trajectory and how our tools become more powerful ways of understanding concepts. I'm just thinking about, you know, because we did a session on visualizations 2 or 3 weeks ago, just kind of talking about the power of tools like, you know, that NOAA has to understand climate concepts sort of at the macro level. And I've always thought like the most immersive and interesting stories have to do with understanding like the concept of regional climate shifts happening paired with stories on the ground of what's happening. And those folks, you know, us here in the Bay Area, why are these atmospheric rivers happening more frequently? Why are we predicted to be in sort of a drought scenario moving forward? You know, things like that. I think there's a lot of power. So I'm thinking about like what you were saying. It's like a level up with VR, because now you've got, you kind of go from like writing to photographs to video to different types of video. I'm thinking about like drone footage and how drone can give you this sort of global perspective from a different position. And then what you're introducing with VR, the idea of personal experience of someone else's experience. You know, I think that that's incredibly powerful. So I don't know, just more reflecting and curious about any of your findings around even elaborating a little bit more on this idea of immersion, of really representing, you know, so understanding somebody else's position, right? As we might understand from drone footage or from you know, imagery and things, we get a different perspective. And I'm just thinking also personally, anecdotally, about when I put on one of those headsets, the Oculus headsets, like 10 years ago, like your brain remembers that stuff. Like it's a little scary in a way, because like you're saying, if it's used for sort of in these violent video scenarios, you kind of have nightmares almost, because it's like you're living that experience and you remember it as if it was a dream. But the other side of it that you kind of introduced is really inspiring, the idea of using it for good, using it for understanding what's happening to our natural environment. So I really appreciate that. And I think we've spent a lot of time in Clean over the last couple of years thinking about changing the narrative of how we teach climate change. So it's not the gloom and doom, it's happening to you, I'm a victim. It's, yes, it is happening. These are the real things that are going on, but look at what we're doing and look at what the difference you could make by adopting one portion of the coral reef or adopting your neighborhood and starting a garden. Look at all the awesome things that we can do at the sort of local level, and then imagine scaling that, you know, taking Project Drawdown sort of philosophy of like, take all these small things, add them up to this really cool, you know, multiplier effect. So anyway, just more reflecting, but curious about any additional thoughts you had around that.
Yeah, I think you're spot on. And to add to kind of what you said as well, I mean, when we tell students words like climate change or global warming, we're often abstracting very complex concepts by using a word that just creates a wall for something that's very complex. And to many children, especially when we worked with kids like in the San Francisco region as well, we would talk about things like climate change and global warming, and they'll be like, yeah, that's happening far away. It's not happening here. It's something that's happening somewhere else. And a big thing that VR enables is the ability to reduce that physical distance. Even that metaphorical distance, it reduces that distance. It disentangles, or it opens up the onion, right? It opens up the doors to show you what the complexities of the space are. And I mean, the $1 million question that you're asking, which there's a whole body of work on, is can VR build empathy? Can it can VR storytelling? So it's not just VR alone. At least one takeaway from our research was that it's 3 things that we're seeing that leads to a change in one's behavior or change in one's attitudes towards a topic. It is first the affordances of the medium itself. So the ability to put you in a first person perspective, giving you manipulative powers and movement powers and all of that, which is unique to virtual reality. So the affordances of the medium is huge and very, very powerful. But along with that, it is the combination of persuasive storytelling. it is compelling storytelling, anecdotes, case studies of humans, of people, which needs to go hand in hand with that as well, for that sort of thing to work. And then the third one is the degree of control that you give the student or you give the learner. Is it a passive experience that they're just watching as a movie, or are they actively like making decisions? Can they choose the pathway or the narrative? Can they actually like interact with the scene or the environment? It's the combination of those three, which is when we have that home run. And we actually are going to be publishing that as even a design recommendation for how one should be designing for VR, by kind of integrating all those three elements into their storytelling artifact. Yes, Karen?
I apologize for having been on my phone earlier. I am now on my laptop and I can make things work. So I'm way behind. I really love what you've described and what you're doing. I want to go back to your first example of walking the plank and the high risk notion of that. And my head immediately clicked in to adults as well as youth being really panicky scared of speaking out in public. And if we're going to get the kind of collective action we need to address these big challenges that we now have to address environmentally, we've got to get more people over that high risk hurdle of speaking in public, and speaking in public in front of school boards, state legislatures, city councils, whatever. And I'm wondering if there's any work that's been done to using what you've just described. And I love your integration with all of the skills and components of the national science standards and so forth. Has anybody dealt with actually citizen participation in governance as a high risk venture?
Yeah, those are all fantastic questions. I think my short answer to you is we are barely scratching the surface of what this technology can afford and what it can do. You gave a couple of examples of public speaking. That's been done. If you just Google VR public speaking, we had some experiments at Stanford, as well as you'll find a million experiments out there where they'll teach you, like, it's all around like, well, let's put you on a stage and have you practice in front of an audience, or virtual audience. And now you can do interesting things, like maybe the audience is cooperative, maybe the audience is non-cooperative. Like you can do all sorts of training that would not be possible in the real world. The audience boos at you, the audience ignores you, the audience interrupts your presentation. You can imagine the use cases for this, for teaching, for training people in leadership roles. There are all sorts of other things where VR can be used for themes and topics that might be too dangerous to do in the real world. Like in California and the Bay Area, I know that the Stanford VR lab has been working a lot with the Palo Alto firefighting department around earthquake preparedness and training. So it's like you're in a warehouse and earthquake happens right now, which is very common, but you don't want to train people when the earthquake happens. You want to train them before it happens. So it's like an earthquake started, the boxes are falling. What do? You have 10 seconds. Figure out what you have to do. How do you find cover? How do you help somebody around you? And so, and now you can increase the risk levels of the earthquake. You can have different scenarios that you can develop and map. So the opportunities are incredible here. The way Jeremy Bailenson describes it, which is really cool, is he has a framework called the DICE framework. That's DICE for VR, which is, he says you want to identify use cases for VR to do things that are either too dangerous to do in the real world, simply impossible to do in the real world, counterproductive to do in the real world, or are expensive to do in the real world, DICE. And those are the best use cases for virtual reality. And if your intervention or your idea does not fit in this framework, then it's probably cheaper and easier to do this in a non-VR use case. And there is a lot of VR out there that should not be in VR. It's in VR for the sake of being in VR because it's cool. But when you apply a simple framework like DICE, and there's many such frameworks out there, you kind of hone in on the true affordances that this medium brings to the table. And the opportunities are incredible. I mean, I didn't even talk about the healthcare use cases. People at the med school at Stanford are exploring non-invasive anesthesia with VR for young children. If a young child needs to be vaccinated with a flu shot or something, put them in a VR headset and they're playing a game. And in the game, when the character pushes you is when the doctor injects the needle. And then they put EEG scanners on your brain and they show that the pain receptors do not trigger. when the kid is in the VR headset. So it's like physiologically, we're able to see changes by immersing you in a VR experience. It's not just psychological, but it's physiological changes as well that are possible. There's PTSD and trauma and therapy use cases for VR by doing exposure therapy, tackling phobias, fear of heights, fear of spiders, fear of public speaking. There are immense opportunities for exploring what this technology can offer. And again, I think we're just getting started. The C stands for counterproductive. A good example is in like a climate change context, for example, there was an experiment that we did in VR around tree cutting, where we had kids go and cut a tree in a virtual environment. And then we showed the effects of cutting the tree and helped build empathy towards kind of why you shouldn't be cutting a tree. Now, you don't want someone to go cut a tree in the real world, but you want them to do that and see the physical effects of doing that in a virtual context. That's a good example of counterproductive.
Thanks.
Well, thanks, everyone. I'm conscious of us being at the end of our time together. Thanks for a fantastic, super interesting presentation. And I hope everyone has a great week. We didn't have time for announcements, but if anyone wanted to throw some stuff in the chat to read, we can stay on for a little bit for that. But otherwise, go forward and do good stuff. And look for signs of spring.
Thank you. Thanks, Kristen. Thanks, Aditya. Great presentation.
Thank you, everyone.
Thank you.